Okay, so Zp is 2 into 1 plus j ohms. Okay, Zp is, so the voltage then is equal to 2, then the current I is V over Z parallel, which is 2 divided by 2, which is 1 plus j. Let me see. Did I have a sign error?
Yeah. Shouldn't it be minus j minus 1?
This is right. I reciprocate this, right?
Yeah.
I reciprocate this. I get this. I get this. So where did the sign error come from? 1 over Zp is j omega L.
Should that be negative 1 plus j?
Let me think. Okay, I get it right actually. I get it right. And if I reciprocate this one, I get 1 minus j over 2. Okay, if I reciprocate this one, I get 2 in the denominator, I get 1 minus j in the numerator.
That's right.
Okay, and this one in polar form is equal to half. If I take the polar form of this, I find its magnitude square root of 2. And then the angle is what? Plus or minus? What is the angle? What about you? What is the angle made by this?
45, negative 40.
Negative 45. So in radian form,
Pi over 4.
pi over 4. Okay, so that is that current in terms of amps, and then you need to convert this back to time domain. Okay, so you multiply by e to the j omega t and take its real part. This is actually 1 over root 2 cosine of omega t minus pi over 4. Okay, that is the answer. Omega equals 2. Okay, this is equal to 2. Okay? Okay, let's look at example 413, which is another example that the book has. Okay, example 413 is something similar, but something in series connection. So I have this circuit is in its original form. And then this is equal to, well, this is a resistor, sorry. 1 ohm. And this is 1 farad. This is a capacitor. And then the first thing I need to do is to find the phasor form of this circuit. Okay? So if I find the phasor form, this would be something that looks like this. What does this become in phasor world? 1, very good. 1. You're my favorite student. Okay? Just for that occasion. What about this one? What is omega? You have to also keep in mind what omega is. Omega equals 1. Okay, so this is 1 over j omega c. Z is equal to 1 over j omega c. C is equal to 1, omega equals 1. And what would this impedance work out to be? Minus j. Okay, if you work this formula out, and this remains to be 1 ohm. So this is something interesting in the sense that the impedance now is not a pure imaginary number, nor a pure real number. Okay, the total impedance, Z series, is minus j plus 1 ohms. This number is neither pure real nor pure imaginary, like what you had encountered before, but this number is a complex number, just like this one also over here. This is a complex number. Okay, so 1 minus j ohms. And then if I were to figure out the current I I would be equal to V over Z series, the total impedance that this voltage sees, okay? And that would be equal to 1 divided by 1 minus J amps, okay? And this one is equal to 1 divided by 2. I take the magnitude of this. A squared plus B squared is 2, and then 1 plus J amps. And then if I take the magnitude and phase of this, it will be root 2 e to the J what? What is the angle that you see? Pi over 4, okay? Amps. And then you figure out what IT is. You take e to the j omega t, and taking its real part, cos of omega equals 1, cos of t plus pi over 4. Okay, that is what IT should be. Okay? Okay, any questions so far? We have 5 minutes, we can do one more example. Okay? We have 5 more minutes, we can do one more example. Let's look at example 414. Okay. Because of lack of time, I will just write down the phasor diagram directly. Okay, you can look at the original diagram in the textbook. Okay, the phasor circuit will be just this one over here. I'm sure you know how to go from the phasor circuit to this one. Omega equals 4 in this phasor diagram. Okay, you have a resistor, there's 8 ohms here. And then you have an inductor that is originally 2 Henry but converts to J8. Okay? And then you have a capacitor that was originally 1/16 of a farad. And that converts to minus J4. Okay? I wouldn't write down the original diagram for you.
Was the current source given like that?
What?
What was the current source given as?
The current source was originally 2 cosine of 4t minus pi over 3 in the time domain. Okay, I just convert that into its phasor form. Okay? So, what you need to do now is actually to find the current I. Let me see. It asks to find the current I. The current I in this branch. Okay, ask you to find I in that branch. So you use a current divider formula. Use a current divider formula. And the current divider formula is that I should be equal to 1 over Z1 over 1 over Z1 plus 1 over Z2 plus 1 over Z3. Okay, so actually it is this formula. Y1 over Y1 plus Y2 plus Y3. This is called the current divider formula. The voltage divider formula would be R or Z1 over Z1 plus Z2 plus Z3. Okay, they are of the same form.
Multiplied by I naught.
What?
Multiplied by I naught.
That's right, multiplied by I naught, the I, okay? The I naught that goes through this circuit. And this is the E naught. Okay, so those are the current and voltage divider formula. Thank you for pointing that out. And then if I were to apply and try to figure out how much current would go through this branch. If this branch has very high impedances, the current will be very small. But if this branch has very small impedance, the current will be very high. So you can figure out I is equal to 1 over 8 divided by 1 over 8 plus then 1 over z2, which is j8 plus 1 over j4, okay, minus j4. So I worked that out. It takes quite a bit of arithmetic. Do you want me to work it out? Why not, right? Oh, I have only 2 minutes left. So if I work this out into a polar form, then you can convert it back into the ordinary time domain form. Okay, I naught is actually, I have to multiply by I naught. I naught is not that trivial. I naught is 2 e to the minus j pi over 3. Okay? You have that formula. Actually, this simplifies to something rather simple. Okay? That is not too bad. Okay, if you work this out, this simplifies to something that is rather trivial. So if you look at this, this would be equal to j8, j4 over
I think it's j by j minus 1.
j8, j4, right? Plus 8 j4 minus 8 j8 or something like that, okay?
It's j by j minus 1.
Yeah, it simplifies to something very simple according to what I have over here. Okay, the 8 cancels each other. And then it simplifies to something really simple. J8 minus J4. Okay. So it simplifies to something really simple, which is 32 over J4 or something. Which is minus J8. Okay, so this number simplifies to something very simple. Okay, you can go and work on the details.